This instructional video will show you how to use experimental data from concentrations at equilibrium given a reaction to determine values for the equilibrium constant. In order to do this, we'll need to know the form of the equilibrium constant expression, which we have here, and we've already balanced out the reaction. So given these pieces of data, we can determine what the equilibrium constant value is for each of these trials. So the first thing we have to do is make sure that we're plugging everything in correctly. So 1.767 times 10 to the minus 2 gets squared because it's the concentration of the hydrogen iodide. Next, we want to divide by the concentration of our hydrogen, 1.831 times 10 to the minus 3, and the concentration of our iodine, which is 3.129 times 10 to the minus 3. When we go through this entire calculation, we get a value of 54.5. For our next one, trial number 2, works mechanically exactly the same. 1.559 times 10 to the minus 2 squared divided by 3.560 times 10 to the minus 3 and 1.250 times 10 to the minus 3. When we evaluate this expression, we end up with the value 54.62 for our Kc value. And for experiment 3, we're going to do the same thing. 1.354 times 10 to the negative 2 squared. We'll divide this by 4.565 times 10 to the minus 3 and 7.378 times 10 to the minus 4. And when we complete this expression, we get 54.43. Now, to get the average Kc, we'll just add these three values up and divide, and we find that the average value is in fact 54.5. So by doing this, we're able to show that when you have a balanced reaction and the equilibrium constant expression, you'll need sets of data for concentrations of the components of the reaction at equilibrium. Once we step through that, we can determine Kc values for the individual trials and use the average value going forward as the true equilibrium constant value for this reaction.